Okay, welcome to the screencast. We are with Chapter 5, Section 5.4, using the sum and difference formulas. In this case, the example is to verify one of the cofunction identities. So we know that the cofunction identity says cos of pi over 2 minus x is equal to sine x. And we can prove that because we now know a formula that says if I have the cosine of the difference between two angles, well, that's equal to a specific formula. Okay, so return to slide here for us. Let's go back here. I've got the cosine of the difference of two angles right there, and I'm going to apply that formula. Okay, so go ahead and give that a try. See if you can simplify it to show that the left side indeed equals the right side in that case. Okay, just work on the left side, and you should be able to show that you have just sine x. Okay, give that a try. Okay, I've just worked that far to show there's that formula that I had, and if we take that, the pi over 2 is going to be our first piece, so u is the pi over 2, and then v in the formula is going to be our variable x. We can substitute, and we've got to here cos pi over 2 times cosine x plus sine pi over 2 times sine x. That's what the left side is. And then what you can do from there, provided that you can appreciate that you have now some simplifying possible, because you have an actual angle in there, pi over 2, and we can substitute the values of cos pi over 2 and sine pi over 2. Remember that corresponds to an ordered pair on the unit circle that you see I've drawn over there. Cos pi over 2 is 0, and that would be multiplied by cosine x still, and then we have sine pi over 2, which is 1, and that's multiplied by sine x, and then lo and behold, 0 times cosine x, this term right here, turns into just 0, and you've got sine x. So you've shown that the left side is equal to the right side. Okay, so that's an application, one type of application that you might see in some problems or on an assessment about applying a cofunction identity. It might not be quite as straightforward as this prove, but you might use a cofunction identity or maybe some other combination of angles, and in which case, you know, you're going to see that we'll be able to, if as long as we choose these angles properly for you, you're going to be able to cancel some stuff as you see here. Okay, so that's example 5, nice application to start with. Example 6 has 2 parts. Okay, so these are something known as reduction formulas. Okay, so a formula, if someone for some reason had cos of some theta minus 3 pi over 2, we can use our cofunction identity, once again the cos of a difference, to make a simpler formula. So that's really what you're doing here. So go ahead and give that a try. So write that expression as a function of only thetas. Okay, so we're going to expand this. I guess it's going to feel a little bit like expanding, not in the sense of the distributive property, of course. We're not expanding like that. We're not multiplying cosine by that. No, what you're doing is applying that same formula from the slide before into this situation. So see how far you get. And of course, with a hint here that you're going to need to make use of, once again, that unit circle in those ordered pairs, because 3 pi over 2 is going to come into play. Okay, give that a shot, see how you do. Okay, hopefully you managed to get that far, which is to say all the way to the answer. I used the formula once again. Expanding, I guess, is the best way to call it, but not to be confused, like I said, there with the distributive property, which also has the command term of expand, a little bit like our log formulas, I guess, these problems. So we did so properly. We got the cosines multiplied together and then add that to the product of the sines. And in this time around, actually we've returned back to a 0 because we've got cos 3 pi over 2. So that first piece is going to turn into 0. Cos theta times 0 is going to be 0. And then sine theta this time is multiplied by -1 because we are around to 3 pi over 2, which is down at a y value of -1 in the unit circle. So you have a formula here, a trigonometric function with only thetas where the cosine of some theta subtract 3 pi over 2 is actually just the same as the negative of whatever sine is of that same angle. Okay, so just theta in there. Okay, that was part A. Similar sort of idea comes at you in part B. Reduction formula, this time around tangent. So I think this is the first example involving one of the tangent addition or subtraction identities, formulas. So give that one a go just straight away. There's the formula. you can go ahead and call theta u. So I'm going to write that down. I'll put that down here. Let theta be the u, and let 3 pi is going to be our v. Okay, and then just apply the formula and see how you do. Okay, so there you see the substitution and the result, which takes us all the way down to an expression that says that actually the tangent of theta plus 3 pi is going to be the same as the tangent of just theta by itself. And we do have a way to understand that result, because we know that the period of the tangent function, right, if I start talking about its graph that we learned about, it repeats every 1 pi. Okay, so some angle, let's say a nice easy one up here in the first quadrant, let's say it was a pi over 4, 45-degree angle, it would have a tangent ratio of 1. And then if we swing around 1 pi later into the third quadrant, we have exactly the same again, because it's y over x, and we all know that the tangent ratio is positive in that quadrant too. That's a half turn later, and then again a half turn later. So that's every 1 pi. And so that's this formula, theta plus 3 pi, can make some sense to us once we get to that bottom result. Okay, that is example 6 for us. The next example is an equation where we're going to use the sum and difference formulas to simplify. I'll put that in quotes because it doesn't feel like we're simplifying at the start, but indeed we will be doing that. Okay, so I'll just set that up and we can try it out. Okay, so example 7, solving a trig equation. We've solved several trig equations so far, nothing like this though. So this one says find all the solutions of sine x plus pi over 4 plus the sine of x minus pi over 4 equals to -1. Okay, and in the interval of 0 to 2 pi. And then this last piece, as you recall, this last piece right here means that we're not going to have to add 2 pi in. Okay, not going to add 2 pi in. We just have to find some angles. Okay, so now how are we going to do that? It has to occur to you. You look at this thing similar to, but quite a bit different usually for the students to understand this one, is to recognize that you've got a sum and difference formula sitting in front of you, and then as it says over there in the margin, we have to apply those two formulas. So the sine of a sum is what they call that one, and then the sine of a difference of two angles. That's what you're going to have to do first. Okay, so I've put a box, blue box around one of them and a red box around the other one. Those need to be replaced with their formulas. Okay, so back again to that first slide where it was before. You would have to consult a formula sheet, so that's what we're doing here. We know that we have a sine of a sum, so we're going to have to replace, it turns out, what looks like quite a compact statement is going to be replaced with this stuff, and then also the difference. So you're going to go ahead and do that, and just as a preview, get back to it, sorry about that, flipping around. Just like we had with that other couple of problems, you are going to have an angle get involved here at some point. So you're going to have sine of x, but you're also going to have sine of pi over 4. And you're going to have cos of x, but you're also having cos of pi over 4. Okay, so there's also some evaluating that's going to happen here. So don't think that you're going to be left with nothing else to do on this next step. Okay, so do the substitutions just to make sure we get those correct, and then we'll proceed from there. So we'll set that up and then go from there. Okay, so what is in the blue box on the top turns into what is the blue box on the bottom. They're equivalent. That's why I put those boxes around there again, just to try to give any way that I can to give you the idea. You know, that's what those formulas do, is they, you know, again, it's expanding, but it really is actually simplifying, as you've done in the past. I know it doesn't feel anything like adding, subtracting, multiplying, dividing. That's not what you're doing. You're replacing by a formula. So you have to be able to spot that. How do you do that? Well, the signs of things that are inside there, called the argument, the thing that's being sign ratioed, it's a sum or a difference. And so you have a formula for that, and you can do replace. Okay, so what does that get us? Okay, well, we've got sine x times the cosine of pi over 4. We've got the cosine of x times the sine of pi over 4. Of course, those are different. And then you go into the red box, and you've got sine x times the cosine of pi over 4. Hang on a second, I've seen that before. Those are the same thing. These two guys are the same thing. So you got two of those. That's good. And then you've got, once again, this time around, minus cosine x sine pi over 4 to go with an offset, I guess if you want to call it like that, exactly offset what you had in the blue parentheses. So what ends up happening there is you've got you got some canceling, and then you've got double of something. So this first piece is double of that. So you've actually got 2 sine x cos pi over 4, which feels terrible, but at least you're simplifying. Collecting like terms really is what you're doing, believe it or not. Cos pi over 4 is a value that you know, and we're going to work with that in a second, but that's what you've got. You got sine x, don't know what that is, but I know cos pi over 4 is something, and then of course I've got another one of the exact same things. I have 2 of that thing, and then this is I have 1 of those, and then I can subtract 1 of those, so I got none of those anymore. And then leave the -1 on the other side, but don't forget the -1 on the other side. Sometimes that, with all this other work, the -1 gets left out, and you end up with the wrong solution because you have 0 on the other side. So don't do that. Okay, so now you know what this is looking like and where we're trending towards. I'll advance it a step and show you what to do there, and then hopefully we can get all the way to the end. Okay, just a quick one here, quick shot. Sorry for all the chopping in and out. Just one step has happened. 2 sine x times the cosine of pi over 4 equals -1. That's what I said before. And now it's the time is to use your memory. You would have memorized cos pi over 4 at this stage. And so that's a number you can substitute in. And then just for the efficiency of the screencasting time, I'll write out the entire solution. You try to do the same thing. You're going to be able to simplify cos pi over 4, and then you're going to have to solve it the rest of the way after that and see how you do. So remember, this is also all solutions between 0 and 2 pi. And so take that into consideration when you're working. Okay, give that a shot and see how you do. Okay, at this stage, quite a bit of work to do. I'm going to zoom in because I think we're past that spot. And now we're at the so-called easier trig equation, starting with cos pi over 4 is √2/2. So we needed to know that. And so you've got 2/1, or at least sine x, times √2/2, and these 2's are going to cancel. As you see in my working in that next line, I brought actually that √2/2 out to the front, which of course you can do because it's this 2 times sine x times this number. So you can change it into any order you like. Bottom line is the 2's cancel, and you end up with √2 times sine x equals -1. Like I said, don't forget about that -1. That's a big deal now because it is going to be divided by √2. -1 over √2 is equivalent to -√2/2. The reason I do that is just to make it more familiar for those coordinates that we have on the unit circle. And there's the working, just the rationalizing of the denominator off to the right, which has been sitting there the entire problem. Maybe you were wondering what that was for. Well, that's what it's for. And then you are finally at the trig part, where you're finding 2 angles. And this is where that interval is important. There are 2 stops on the unit circle, one in the second quadrant. Nope, my bad. One in the third quadrant and one in the fourth quadrant. So we're looking for, if we look at our ASTC rule, if that's the way you want to play it, the sine ratio is what we're dealing with. So we know that the angle has to be either a terminal side in quadrant over here, or a terminal side in quadrant over here. So it's got to be a 3 or a 4, where the reference angle that you're dealing with is, of course, a pi over 4. Okay, and we knew that was going to be what was going on, maybe because of the pi over 4 that was involved in the first place. But you didn't have to think about that, and you never will have to think about that. You just have to get yourself to the correct ratio here on the right-hand side. And then always remember, if you're looking interval between 0 and 2 pi, actually I shouldn't think of an always remember, because we've had all kinds of equations. In this case, there isn't a number in there with the x, so to speak. So we can just straight ahead find those 2 solutions. Okay, don't want to overcomplicate it more than it's already got going for it. That is examples 5, 6, and 7, more use of the sum and difference formulas. Okay, part 1 was done before the break, and now you've got this stuff to see how these formulas work in action, and you can go to with the homework problems. Okay, good luck. Reach out with any problems.